This is lesson 5.2. I can identify zeros of the function by factoring and using the zero product property in Graphing Calculator. So for example 1 here, we're going to practice factoring. This is the same kind of factoring we did in Unit 4. So first look for a common factor. Notice x is a common factor there. Dividing x, we get x squared minus 2x minus 15. This can be factored further. We can factor this middle trinomial. The c value goes on the left. The b value goes on the right. Two numbers that multiply to get negative 15 and add to get negative 2. That works out. So we could rewrite this with the x in front and then the x minus 5, x plus 3 as our second and third factors. Part B, we look again for a common factor. 6 and x are the common factor here. Dividing this by 6x, we get x squared. Dividing 6x by 6x, we get 1. Now this can be factored further. If you recall, this is in the form of a squared minus b squared, which factors into a plus b, a minus b. So we wind up with 6x times x plus 1, x minus 1. So now that we practiced factoring, we can recall how that relates to finding the zeros or solutions or x-intercepts. All of those mean the same thing. So zeros is the same thing as x-intercepts, which is the same thing as solutions. I'm going to rewrite this so it's on one line. Y equals x plus 2, x minus 1, x minus 3. The zero product property helps us find the zeros. So we would replace this y with a 0. And then set each one of these factors equal to 0, recalling that anything times 0 is 0. So x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Subtracting 2 from both sides, we get x equals negative 2. Adding 1, we get x equals 1. And adding 3, we get x equals 3. So now we have our three x-intercepts, negative 2, 1, and 3. The next thing we do on this is to look for our lead coefficient. So we notice this would be an x times an x times an x. So our lead coefficient would be, I'm going to write that down, lead coefficient would be x cubed. So our lead coefficient is found by multiplying each one of our first terms in the sets of parentheses. So that's x times x times x, which is x cubed, which is odd and positive, which would indicate that we have a graph that is down on the left for the end behavior. Our end behavior of our graph is down on the left, up on the right. So we've plotted our three zeros. The next thing we can do to help get a better feel, since we know it's down here and up here, is to go ahead and get out the graphing calculator. You can actually type it in just as it's written in the parentheses and all, and hit graph, and you can see our graph is going to look something like this. So it's a sketch, so it doesn't have to be exact, but we get something like this, where you see the end behavior down on left, up on right, and going through the zeros. For example 3, we'll write a polynomial function from its zeros. What is a cubic polynomial function in standard form with zeros negative 2, 2, and 3. You'll recall to write these as factors, we can set up an equation, so that would look like x plus 2. We do the opposite, x minus 2 and x minus 3. To get in standard form, we then FOIL it out. So we're going to start with the x plus 2 and the x minus 2. You'll notice that that is in the form of a plus b, a minus b. So again, we talked about that on the front. A plus b, a minus b is equal to a squared minus b squared. Noticing that pattern, I could FOIL it out and I would end up with the same thing, but that's going to equal x squared minus 4. Now I'm going to take my x squared minus 4 and multiply that by my x minus 3. X squared times x is x cubed. X squared times negative 3 is a minus 3x squared. We've got a minus 4x and a plus 12. Because these are not like terms, this is our final answer, standard form, given these zeros. What is the quartic? So that means we'll have a degree 4 polynomial function in standard form with these zeros. Something that stands out right away is I have this pair again, just like I had in this previous question. So I'm going to go ahead and write those next to each other since they simplify to a binomial, which is helpful. So I'm going to write this as x minus 2, x plus 2, and then I'm going to write my other, so this opposite is going to be x plus 2, and then the opposite for that 0 is going to be an x minus 3. I know this pair right here is going to FOIL into x squared minus 4. Now I'm going to multiply that by my x plus 2. Distributing, I get x to the third plus 2x squared minus 4x minus 8. And now I need to multiply that by my last group here. So I'm going to multiply that times my x minus 3. We've got, I'm going to try and use some different colors here. The x cubed is my first term, and I'm going to multiply that by my x. So we'll get x to the fourth. And then my x cubed times my minus 3 is going to be a minus 3x cubed. And then come inside and do my 2x squared. Multiply that by both terms here. So I'm going to get a plus 2x cubed. And then I'm going to get 2 times negative 3 is minus 6. And then we've got that x squared there. And then I'm going to come back to my minus 4x. Here and multiply that, and I've got a minus 4x times an x, that's going to be a minus 4x squared, and then a minus 4x times a minus 3 is going to be a plus 12x, and then lastly I've got my minus 8, multiply that, and I've got a minus 8x and a plus 24. Now to combine like terms, it's helpful to go back through and just underline with the number of underlines that matches the degree. There's only one x to the fourth, but we've got an x cubed here, an x cubed here, and it looks like that's it. So that's going to be a minus 1x cubed or minus x cubed. We've got our x squareds. They happen to be next to each other as well, so it's going to be a minus 6 and a minus 4 is a minus 10x squared. And then we've got our x's next to each other, so a plus 12x and a minus 8x is going to be a plus 4x. And then we've got our plus 24 constant at the end. So our quartic, again this degree 4, is called a quartic. Alright, for a few terms that we should know, multiplicity is actually brought up here in example 3, part B, where we have two roots or two zeros that are the same. We have negative 2 mentioned twice. And you can see one way we could represent that would be to write that in factored form as x plus 2, or x plus 2 squared. The definition for multiplicity says that multiplicity is the number of times a zero appears in the solution. For example, we have x cubed plus 2x squared minus 7x plus 4, which would look like this in factored form. The roots then, the opposite of this x minus 1, so that would make a root or a 0 of 1, and then a root of negative 4, or a 0 of negative 4. Now since you see this squared here, that indicates that the 1 occurs twice. So we could say the root, or 0, 1, has a multiplicity of 2. The next two terms are displayed in the graph to the right. Relative minimum is actually just the lowest point on the graph in a particular region. So as you can see, this graph continues to go down infinitely, but in this particular region, the lowest point happens to land here around between negative 4 and negative 6. Relative maximum is then similarly the maximum point in a particular region. Our maximum is infinity, but in this region the maximum is around 3 or 2. Example 4, identifying a relative maximum and minimum. So to do this, we're actually going to use the graphing calculator again. And you can clear out whatever's in there for y equals. Go to y equals, and then enter in x cubed plus 3x squared minus 24x, and hit graph. My window is from negative 10 to 10. It looks like I'm not quite including the whole graph, so this is where you hit window. Actually, my y is negative 40 to 40 right now, but I'm going to go ahead and make that a little bit higher and lower. So I'm going to go from, let's go to negative 60 to positive 60. And we'll keep the scale going up by tens. And we're almost there, but not quite. So let's try 100. You have to wait till it finishes graphing to change the window. So we'll change the window here and go from negative 100 to 100. And make the scale 20. That just makes it less markings on that y-axis. Makes it a little easier to look at. And now you can see the relative maximum here and the relative minimum here. We actually have a nice option here, a nice feature, the calc button, the calculate. It means, so you have to press second, and then the trace key will get you to calculate. And you can click on maximum. And that's going to help us get as close as possible to the actual maximum value there. So left bound is where you want to go just to the left of where you think the maximum is, and then the right bound is just to the right of where you think the maximum is, and then you want to go somewhere in between the two and hit enter, and you'll see there is your maximum value. It says negative 3.99998 and y equals 80. So for our graph x cubed plus 3x squared minus 24x, it looks like our relative max is at y equals 80. And we can actually write that as an ordered pair. So for our relative max, we're going to say round that to a negative 4 and 80. And then we'll do similarly the second calc key and go to our minimum. Scroll over to where you think you're just to the left. Again, this is left bound. Hit enter, go to the right, hit enter, and go in the middle and hit enter. And we'll get an estimate. It looks like it's really close to 2 and negative 28. So we're going to write our relative min is 2, negative 28.